Nails and screws seem boring until you actually have to choose between them and realize that decision can make or break a project. Pick the wrong one, and you get squeaky floors, wobbly furniture, or a deck that slowly tears itself apart. Pick the right one, and everything feels solid, quiet, and trustworthy. Here's what matters when you compare nails and screws in a serious, practical way. Design and structure. A nail is basically a smooth metal spike with a head on one end and a point on the other. It goes into wood by brute force. You swing a hammer or fire a nail gun, and the nail displaces the fibers as it drives in. The shank may be smooth, slightly textured, or ringed, but overall the holding power comes from friction between the metal and the wood fibers pressing back. Screws are a different animal. They have a threaded shank that cuts into the material as they turn, and their heads are shaped for drivers, Phillips, Torx, slotted, hex, and so on. Instead of being smashed in, they are twisted in, which means they form something closer to a mechanical connection than a friction-only one. That difference in how they are driven is not cosmetic. Nails are flexible in the sense that they can bend under load, which can actually be useful when the structure is expected to move. Screws, with their threads and hardened steel, bite hard but are more likely to snap cleanly if overloaded sideways. So, at the design level, nails are about fast, forgiving fastening, while screws are about precise, controlled gripping. Holding power. When people talk about holding power, they often mean one thing: how hard is it to pull this fastener straight out? Screws win that contest almost every time. The threads on a screw dig into the wood or other material and create resistance along the entire length of the shank. You are not just fighting friction, you are fighting a spiral of metal that is literally anchored into the fibers. That is why you can hang heavy cabinets, attach deck boards, or fix hardware with screws and trust that they will stay put under constant tension. Nails rely mostly on friction. Once the nail is driven, the compressed wood grips the shank, and if that shank is smooth, there is only so much holding power you can get. Ring shank or screw shank nails improve this by adding ridges or twists, but they still do not match a properly driven screw in straight pull-out resistance. This is why nails can slowly work loose in applications that see repeated vibration or movement, like old stair treads or floorboards that start squeaking over time. The bottom line: if you care about something staying clamped tightly and not backing out, screws usually serve you better. Strength and durability. Strength is not just about which is stronger. It is about what kind of force the joint will see. Nails tend to be better in shear, which is the force that tries to slide two pieces past each other and bend the fastener sideways. Because nails are more ductile, they will bend before they break, and that bending can actually keep the structure together under lateral loads. That is one reason framing carpenters still rely heavily on nails for load-bearing walls and trusses. The structure can flex a bit without the fasteners suddenly snapping. Screws excel in tension, the force that tries to pull two pieces directly apart along the axis of the fastener. A good structural screw can resist being yanked out far better than a nail of similar size. The catch is that many common screws are harder and more brittle than nails. Under sharp side loads, especially if the wood moves or shrinks over time, a screw can crack or snap where a nail would just bend, so durability is context dependent. For long-term clamping and resistance to pull-out, screws come first. For handling shock loads and side forces in structural lumber, nails still have a very strong case. Installation and speed. If you want to understand why job sites love nails, watch a skilled framer with a nail gun. Rows of studs, sheets of plywood, entire walls go together in minutes. Nails are simple, fast, and easy to drive in huge numbers. Even with just a hammer, once you have the rhythm, you can sink a nail in a few solid blows. That matters when labor time is a major cost. Nails are also more forgiving during installation. If you are slightly off angle, the wood compresses and the nail still grabs well enough for many rough construction tasks. Screws are slower by nature because they require rotation. You need a drill or driver, bits that match, and a bit more care with alignment. The upside is control. You can drive a screw halfway, adjust your alignment, then snug it down. You can stop before stripping the material, then tighten just enough to bring two pieces into perfect contact. For fine work, repairs, or anything where you want to be able to go back later and tweak things, that slower process is actually an advantage. It trades raw speed for precision and adjustability. Cost and practical use cases. Nails are usually cheaper per piece and, in bulk construction, cheaper per joint. For framing walls, attaching roof sheathing, or building temporary forms, that cost difference adds up fast. Combine price with installation speed, and nails become the obvious choice for large-scale structural work where hundreds or thousands of fasteners are involved. The rougher the job, the more nails make sense. Screws tend to cost more, but you get that cost back in specific ways. Decking screws keep boards tight and resist the constant swelling and shrinking that can back nails out over time. Furniture and cabinetry screws allow you to assemble, disassemble, and adjust without destroying the wood. Drywall screws are designed to sink just below the surface without tearing the paper. In all of these cases, the slightly higher price buys you better long-term performance, easier maintenance, and a cleaner result. So the practical rule is simple: nails for fast, structural, often hidden work; screws for precise, adjustable, often visible work. When to choose which? Here is where it all comes together. If you are building a stud wall, putting up roof trusses, or nailing down subfloor, nails are typically the right call. They are fast, they handle shear loads well, and building codes and tools are built around that reality. Let me explain it this way. In heavy structural framing, the wood members themselves are doing most of the work, and the nails are there to keep those members in the right place while the loads move through the whole system. If you are building a deck surface, hanging cabinets, assembling shelves, or doing any task where you want clean alignment and long-term tight joints, screws are usually the smarter option. You can drive them carefully, back them out if something is slightly off, and trust that they will not slowly creep out under vibration or seasonal movement. The bottom line, neither nails nor screws are better in some abstract way. Each plays a specific role. The smart move is not to swear loyalty to one, but to understand what the joint needs to do and choose the fastener that matches that reality.